Finally, we move on to what may be the biggest philosophical question that our study of the universe raises. Are we alone in the universe? To explore this question, I spoke to Hayden Ranpadarath, a PhD student at Curtin University, who has researched this question. So Hayden, you're a radio astronomer. What's your particular area of expertise?
My particular area is applications of a technique called very long baseline interferometry, or VLBI for short. It's the technique where you have telescopes, radio telescopes separated by hundreds of thousands of kilometers apart, and you combine those signals to create a telescope essentially the size of that maximum separation. One of the main properties is that it's the highest resolution in astronomy to date. It's such that you could see a coin 10,000 kilometers away.
Assuming, of course, that the coin is giving out radio waves. Yes. Yeah. Okay, so I understand that you've used this technique of VLBI to do studies on searches for extraterrestrial intelligence. So how does VLBI help with that?
Well, one of the areas affecting current SETI experiments is being able to separate local interference from mobile phones and satellites and TV transmissions from your real SETI signals. And VLBI helps in that sense because you have telescopes separated from 100,000 kilometers apart. One telescope sees a mobile phone or a satellite passes over, another one doesn't see it. When you combine those signals, what you do see together is that common signal from your extraterrestrial intelligence.
So with VLBI, you are blind to anything nearby that could be coming from the Earth, and you're able to look distant into the universe.
Yes, that's true.
Okay. So how did you go about testing this technique?
We tested this technique using the Australian array on a system called Glazier 581. Glazier 581 is very good. It's near perfect in the sense that it's very close, 20 light years away, and there's a planet in the habitable zone where such that you would expect water to exist.
Okay, so this is exactly where we hope to find alien life on these planets that are just the right distance from their parent star. So you pointed your telescopes at this particular solar system just 20 light years away from our own solar system, and you searched for systems. You searched for signals. Yes. What did you find?
Nothing to date, no. We didn't find any evidence.
So is that the definitive answer? No life on GL581?
Oh, no, of course not. Because there's a large parameter space to search for in SETI, in the sense that you have multiple frequencies to search over. Time is another issue, and even the power or sensitivity of your instrument. For instance, we observe in one particular frequency, they could have been emitting at another frequency. At the time we were observing, they would have probably been behind their star, or they may have been on lunch break or not emitting at that time. And then they may have been emitting, but at a lower power than what we expected.
So what kind of powers can you see with the instrument, the long baseline array that you used? Are you able to see just someone chatting on their mobile phone at this distance, or is it only a specific targeted signal that they are deliberately sending towards the Earth?
It's kind of a bit of both. You would probably be more sensitive to a signal beaming directly towards us, but not necessarily the case, because you have systems like the Arecibo interplanetary radars, and we will be very sensitive to something like that.
Okay, so if we're going to find one of these signals, we can improve our chances by looking at lots of different frequencies and also looking at lots of different targets at lots of different times. So is there any prospect that we would be able to do this in the future?
Yes, a prospect is coming up very close in the future, and especially right here in Australia, called the Square Kilometre Array. It's a very revolutionary and very clever instrument, and we hope to be able to use it for SETI.
Okay, so you would be able to use this whole square kilometre array with its very wide field of view to look for SETI. But if we're going to search all of these targets, presumably that's going to take a lot of time away from the other projects that we want to do with the SKA.
Not necessarily, actually. The SETI, to be able to, with VLBI type SETI, is that it's very flexible, that you don't have to take away time. You could just, because you have this very wide field of view with the SK, you could just take the data from someone looking at a black hole and just search that entire data set and see, is there a target, is there a SETI target there? And then we just apply our technique to if there is one or not.
Okay, so because of the wide field of view of the SKA, we can, when someone's looking at a particular part of the sky, looking at a black hole or something like that, or at the epoch of reionization, we can just reprocess that data in a way which is looking for signs of extraterrestrial intelligence in that whole area of the sky where
Yeah.
the telescope's pointing.
Yeah.
And I guess if we did find a signal, that would be a really big deal, right?
Oh yeah, it would probably be the greatest discovery ever in the history of mankind.
So even if there's not much chance, then we should be
I
looking.
believe it's worth a try. Yes.
Well, I'm very pleased to know that there's someone out there who is thinking about these things, and I wish you the very best of luck in making this great discovery in the future.
Thanks a lot.
Ever since it was realised that other planets are worlds and that other stars are suns just like our own sun, people have speculated about the possibility of life on other planets. As we've discovered in recent decades that other stars do indeed have planets going around them and that some of these may be capable of hosting life, that speculation has only increased. It's still a huge unknown whether there are other civilizations out there and whether they would be using radio waves in the way that we do. And some people would say that it's crazy to use radio telescopes to search for extraterrestrial intelligence in this way. I would say that it's crazy not to. If we ever found a real detection of a signal from an extraterrestrial intelligence, it would be one of the greatest scientific discoveries in history. Over the last 4 modules, we've covered a really wide range of astronomical discoveries. I hope there's been something in there to inspire all of you, and I hope you've also gained some insight into the process of science and how we make these discoveries. I hope also that you're as excited as I am about the future of science and astronomy. Big science requires people with a really wide range of backgrounds on board to help us complete these big projects. So maybe there's something where you can help us. My field is radio astronomy, and I hope I've been able to share some of the excitement that I feel for my subject with you. But I also firmly believe that astronomy is for everyone. All of us can participate in astronomy in some way, even if it's just stepping outside once in a while and looking at the sky. So thanks for joining me on this journey, and I wish you the best of luck with your future studies.